Buddy, we're gonna do the OneNote thing again real quick because we probably have close to 10 new people that weren't here on Thursday or whatever. So if you were here on Thursday and you already signed up for this semester's OneNote, you can ignore everything we're gonna do for the next 5 minutes or so. If you weren't here on Thursday, get out your tablet, fire up Microsoft Teams.
Oh, we got front right, middle right, middle. Yeah.
And I'm gonna have to do some add in here.
Far middle right, close middle right. Outside right.
Okay.
outside.
Matt, you said you just transferred in?
Yeah.
Okay. And then
Fourth hour.
you were in fourth hour, now you're in.
It's just showing up.
Okay. Yeah, but you should be third, so I'm just adding you now.
Supply to OneNote.
It connects to the right folder, so it does matter.
Okay, it didn't connect.
I literally just did the third hour add, so it'll take a second for it to add in. That's what I'm trying to sort out here.
It just never did it for fourth hour.
Okay.
That's right.
Okay. Maybe I forgot. Aiden, you said you just transferred in? Okay. Okay. All right. All right. So, and you just changed hours also?
No, I just.
You were just absent?
Yeah.
Okay, so you should be, I should have you already in there. Let's look real quick. Okay, apparently not.
That's what I said. What does this say?
I can't read it.
Will you add me and Sophia, please?
No.
You guys aren't in?
I don't think so.
Okay.
Me and
Bender.
Sophia,
Yep. Okay. All right, so 4, 9, 18. Okay. So I have, that seems right then.
It's not loading. Do I have to be on like school?
You should be in the work and school one for OneNote. Okay, we'll go through this in just a second. I'm just giving everybody a minute to kind of get their stuff situated. All right, so if you weren't here on Thursday, when you log into Microsoft Teams, you should now be able to find a third hour pre-calc tile. I've just added it last of you guys in. If you don't have a third hour tile, try refreshing and looking at it again. Everybody found it? People that weren't here on Thursday? Anybody still looking or still fiddling around getting Teams or whatever set? Okay, go ahead and click on that tile. Once you've clicked on the third hour tile, in the navigation pane on the left, you'll want to pick Class Notebook. So click on that. You should see on the right a OneNote window pop in there. This may take a minute if I just had to add you today. My apologies. Sometimes, depending on how much activity is going on, this can take quite a bit of time for that to load in on you. Hopefully it's not too bad today. I don't imagine everybody's connected trying to do all their stuffs today, but it might still take some time. Once that loads in, all you need to do is go to the drop down here where it says open in browser and select instead open in desktop app. That'll open up the OneNote and add the shared page that I made for you into your OneNote. So it should be, that should set everything for you once you're able to do that. Again, it will take a minute if I had to add you today, Sophia. It's just going to take some time to load that in. Class notebook. And then it'll take some time for the OneNote to come in and compile. It'll get there eventually. It may take 20 or 30 minutes, though. I've seen it take a long, long time, depending on how much traffic is going on through the network. So I tried to do this all in advance, but I just made a mess out of this hour. This might have been the hour that I just forgot to do somehow. Like I made it and then I didn't really finish it or something. I don't know. Okay. Once you've done that, you can close Microsoft Teams. If you're still waiting for things to load in, just minimize it or whatever. It'll load in the background. You can come check it again in a few minutes. The other thing that we need to do is we need to, again, if you weren't here on Thursday, you open up My Notre Dame. So those of you that weren't here on Thursday, open up My Notre Dame. And under the links heading, there's a link that says Delta Math registration. We're going to sign up for a new Delta Math section. So if you click on that, it'll open up right to Delta Math with the class code already typed in there for you. All you have to do is pick register with Google and pick your school Google account, and you're done. So it's like the easiest sign up ever. Mr. Kulik's an all-star. Because that was super duper easy.
Matt, what's that? I'm worried.
We did stuff the first day. The good news is there's a video that you can watch, and the notes are in the OneNote. So, like, I make it as easy as I can for you to miss something. You know what I mean? All right. So let's recap here where we had left off. So on Thursday last week, we talked about the law of sines. We identified that there's 3 situations that we use the law of sines in, where we have angle, side, angle. So situation where, like, we have a situation like that where we're given 2 angles and the side in between the angles. We can use it for angle, angle, side, where we're given 2 angles and then a side not in between the 2 angles. And the third situation is where we can do it is if we have an SSA. So that's where we're given 2 sides and not the angle in between the 2 sides. Everybody's okay with that? These first 2 situations are easy. You only get, only one thing can happen. There'll always be a triangle possible. It'll only be one triangle possible. You don't really have to think hard about it. You just grind through the law of sines to find your parts that you need. The SSA situation is tricky, though, because lots of different things can happen. So to figure out what's going on here, the first thing we have to do is look at the given angle. If that given angle is obtuse or right, some stuff can happen. And if the given angle then is acute, different things can happen. Okay? So if our angle is obtuse, if the opposite side, in this case, in my picture, that would be y, the side that's opposite the given angle, is the shorter or the same as the other side, no triangle is possible. It's a problem you cannot do. If it's the reverse, where the opposite side is the bigger, then just one triangle is possible. If the given angle is an acute angle, and the opposite side is the bigger or equal to the other side, that's fine. One triangle is possible. But if that opposite side is shorter than the other side, we don't know immediately what's going to happen. It could be 0, 1, or 2 triangles. So where we left off on Thursday, we're doing an example of a situation like this, where we can talk about how to tell which one happens. Okay? So let's go back and look at our example. So I went and drew myself a picture, and I labeled it. Now, when I'm labeling a picture here, we have to be really careful how we're doing our labeling. You can't just label things all willy-nilly. So when we label a triangle, we use capital letters for the vertices of our triangle. And it doesn't really matter which capital letter you put where, but if I've labeled this vertex as A, the side opposite that has to be labeled with an A also. If I labeled this one as B, the side opposite that has to be a B. If I label this as C, the side opposite that has to also be a C. Everybody's cool with that? If you label your triangles incorrectly, the formulas will not work. Got to remember to, when you're drawing your picture, to label things correctly. Okay? Okay. So I drew my picture. I'm observing that I have two sides, but the given angle I have is not in between the two sides. So this is an SSA situation. The angle that's given, angle B, is acute. And the side opposite the given angle is 10. The other side is 12. So the opposite side is shorter than the other side. So this is that, what we call the ambiguous case, where we can have 0, 1, or 2 triangles possible. To figure that out, I'm going to set up my law of sines. So I did sine B over B equals sine A over A. So that's cap B. That's little b, cap A, little a. I went ahead and then cross-multiplied to solve the proportion, and then divided by the 10 to get sine A by itself. And this number here is going to tell me whether I have 0, 1, or 2 triangles. If that number is greater than 1, 0 triangles. If it's equal to 1, there's 1 triangle. If it's less than 1, we get 2 triangles. Everybody's okay with that? So when we type this into our calculator, we got 0.892. So we know we're going to be getting 2 sets of answers because there's 2 triangles possible for a this situation. It's okay. So triangle 1, to solve, I need to solve for angle A, angle C, and side C. That'll be, those are the missing parts of the triangle that we're given. And then I'll label for triangle 2, I'll also be looking for angle A, angle C, and side C. To differentiate these, I'm going to have subscripts. So I'm going to do a subscript 1 on each of those variables for triangle 1's dimensions, and a subscript 2 on those variables for triangle's 2 dimensions. It's really important that we're able to kind of keep our work straight and know what numbers go in what triangle. Oftentimes I see students have a lot of problems just because they're not organized and they're confused at like what stuff belongs where and where do I use this number versus that number. So I try to be really clear and organized when I'm doing this. So to solve the first triangle, I'm just going to start with where I left off with, was that sine of A was equal to 0.892. Now to solve for that angle A, I did the sine inverse of both sides. And when I type that into my calculator, I get 63.10. That's my answer for angle A in triangle 1. So I labeled that as A1. To find angle C, I know there's only 180 degrees in the triangle. So once I have 2 angles, I can find the third really easily. So I did 180 minus angle B minus angle A1. And that'll give me my angle C1. Now that I have that, I can set up another law of sines where I did sine of B over B equals sine of C over C. And again, to solve this, I'm going to cross multiply and then divide. So C2 times sine 48 equals 10 times sine 68.9. And then to get the C by itself, I divide both sides by sine 48. And I type that into my calculator, I get 1255. Oops. That's C1. I don't know why I put a 2 here all of a sudden. So that's my first set of answers for my first triangle that's possible. Now let's go back and get our second set of answers for the second triangle. Here's the good news. The answers for the second triangle, slightly easier to get than the answers for the first triangle. For the first triangle, I had to do 2 law of sines. I had to do a law of sines to get angle A, and then I had to do a law of sines to get side C. In the second triangle, I'm only going to need the law of sines to get side C. So the first angle I solved for was angle A. So in the second triangle, the relationship between angle A in the first triangle and angle A in the second triangle is that they're supplementary. So 180 minus 63.1 gives me 126.9. Now to get angle C2, well, I know angle B is still 48. That was given to me. That's true for both triangles. And my angle A2 is 126.9. Oh my goodness. How about 116.9, dum-dum? Okay, that's better. It's not 190 degrees in a triangle. Ay, ay, ay. All right, so I do that. What do I get here? I get 30, like 15.1 degrees, I think. Sounds right. Yeah. And then to get angle C2, I'm going to set up a law of sines. So I'll do sine of B over B equals sine of C2 over side C2. Cross multiply. And then to get the C2 by itself, I'll divide by sine 48. And then into my calculator this goes. Before I type this into my calculator, what should I check? Yeah, I checked my mode. So these should be in degrees because all the angles were measured in degrees. I am. But you might have not had your calculator on in, 3 weeks or something. Who knows what mode it was left in. So just type this in exactly as it looks on my sheet of paper. And I get about 3.51. Okay. Yes, of course.
So you're only solving for A, C, and the angles because we didn't get those given to us?
Exactly. Yeah, the directions when we say solve the triangle means find all the missing side lengths and angle measures. So there's 6 total side lengths and angle measures in a triangle. If you're given 3 of them, there's 3 more you got to get. Okay. So we saw in section 7.1, we talked about how to solve a non-right triangle. One tool we could have is the law of sines. The other tool that we're going to have is the law of cosines. So for the law of cosines, we can write it in 3 forms. Bless you. Or no, I retract that. No blessings for hiccups. You okay, hiccup? Okay. My daughter had hiccups on the way to school today. I don't like them either. You know what the Guinness record is for like the longest set of hiccups? Oh no, it's like years.
It's like most of the guy's life.
Yeah, like could you imagine having the hiccups for like multiple days long? Like how exhausted would you be?
Was it 2 2 BC, 2 AC, 2 BB.
Yes. Yeah, if I draw a Z, I'll put a bar in it
Got it.
because my 2's and my Z's look remarkably similar.
Gotcha.
So, yeah, my 2's will always have a bar. Good question.
Just 2's and Z's are remarkably similar. So if it's a Z, you'll have a
That's right. And we can use the law of cosines in a side angle side or a side 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 situation. So let's do a couple of examples here. Sure.
Oh, yeah. Mr. Gordon, I used to be sure.
Of course.
Okay, I'll be straight to point back there.
Okay. So, first thing I'm going to do is draw myself a picture. Now, do I care if my picture is to scale or not? Not me. Could care less. All right, let's take a look at my picture. Notice that my angle is in between the two sides, so this certainly is side angle side. So I know you should be using the law of cosines. So if I'm given angle A, side B, and side C, I know that's the formula I need. Shoo! Yikes. So I'll go ahead and just drop those into my, or drop the values for side B, side C, and angle A into that formula. To get the A by itself, what am I going to have to do? Square root both sides. Now, when I square root both sides of an equation, what am I creating? What do I get when I square root both sides? Plus minus. But A is a length of a triangle, so we never really want the minus. Now, I am going to strongly recommend, when you're typing this into your calculator, typing this all in one line. The majority of the mistakes on these kinds of problems I see students make are they make silly order of operations mistakes where they're trying to do like 5 calculations or 3 or 4 calculations to do this when you can just type it in all at once on your calculator. So I'm just going to do square root 14 squared plus 17 squared minus 2 times 14 times 17 times cosine 34. I'm just typing it in exactly as it looked on my sheet of paper, and I get about 951. Shh. All right. So we have side A. Now we need to find our angle B and angle C. Does it matter which order we do this? Since I'm asking this question, you would tend to think it does.
Yeah, it does.
What is Mr. Kulik afraid of happening?
Because if you don't, maybe it's gonna be like a side angle if you wouldn't know which one.
That's exactly my fear, is if I'm not careful on which angle I do first, well, regardless of which angle I do first, is going to be a side angle situation. What I want to avoid is the possibility of running to a 2 triangle situation, which is yucky. How do I avoid doing this? Nope, not letter order. Is I need to find the smaller of the 2 remaining angles first. So which one is going to be smaller, angle B or angle C? B, very good. Why do I know angle B is going to be smaller? Because side B is smaller. Very good. Good recall, guys. Hey, somebody remembered their geometry. So I'm going to set up my law of sines now. So I have sine A over A equals sine B over B. We'll cross multiply. And then we'll divide both sides by 951. And then, do you guys remember how I get rid of this sine that's out front of my angle? What cancels out a sine?
Inverse sine.
Very good. Sine inverse.
Oh, yeah.
See, I was almost as good as that basket. What's that?
So when I do this in my calculator, again, I want to be very careful. So I'm going to use that fraction command on my calculator, alpha and then y equals, and then pick option 1. So that I can type this in exactly like it looks like on my sheet of paper. Ah, I was afraid of that. Yeah, you just can't see it right now. So I get 5544. And once I have that, how do I find angle C? I rounded.
I got 5.407.
Oh, did you use the whole decimal?
Yeah.
I did ands to get all of the decimal
I
points.
only used 9.51. That's
It's close enough.
close enough.
Close enough.
Just toss it in.
Yeah. We're not worried about like a tenth there or a hundredth.
Never mind.
Oh, is it lunchtime? All right. So
So many new talents.
where we had left off, we were just finishing out this example problem where we used the law of cosines to solve a side angle side. We'd gotten everything we needed. We just were doing a little triangle sum theorem and subtracting. What do we get here? We get like 90.56 degrees. So those are our three values that we needed. The other place we have to be careful about, or that we have to worry about, I guess, when doing a law of cosines, is a side situation. Oops, that's not what I'm looking for.
So if we have all three of those and we're done, practically.
Yeah, we got everything we needed, right? We got the three missing pieces. Let's look at this example here. All right, so here, this is a side situation, right? Really easy to tell. How can I tell right away that it's side? All the letters are lowercase. There's no degree signs next to the numbers. Either of those. Now, we have to be careful in the side situation because not every side, any three numbers don't represent side lengths of a triangle. So we do have to check to see if this is possible. Does anybody remember from geometry how we can tell if a triangle is possible from three side lengths? Not the Pythagorean.
How to check if three side lengths or something.
So if I can make a triangle out of three with three side lengths, if I give you the measures of those three side lengths. So if I give you like 1, 1, and 10,000, obviously you can't make a triangle out of that, right?
Yeah. Oh, doesn't one side have?
What's the rule though? If I give you like 3, 4, 5, can that make a triangle?
The 5 is the biggest.
That's the hypotenuse.
Yeah. Isn't that a rule?
But like, you can have a 1, 1, 1 triangle.
Okay, so
Oh, never mind.
That's
the
equilateral.
The largest side length squared has to equal the two smaller side lengths added together than squared, or squares that added.
No squaring.
Oh,
So leg plus leg has to be greater than the hypotenuse. That's it.
Or I'm saying like.
So that's okay. This is good. So in this case, 5 plus 8 is greater than 10. Sure is. So we get one triangle here. We can do this problem. Everybody's cool with that? So draw myself a little picture here.
We're talking about math, actually.
All right. First things first. We're going to solve for one of these angles, right? P, Q, or R. That's all we have to find are three angles. Which angle first?
Smallest first.
No.
Cute.
Biggest first.
Is it biggest and smallest?
Yeah. So you want the biggest angle first. The reason we want to do that is if the biggest angle is obtuse, we can't fall into that ambiguous case for SSA. Now, if it's still acute, which you can have three acute angles in a triangle, then it really matters which one you pick next because it's like the side angle side situation from before. Yes, Kate?
Did you say check 4 and 0 triangles?
Yeah. Yep. Because if the two legs are the sum of the legs is shorter than the hypotenuse, can't make a triangle out of that. Right? Like my,
Always gotta do that.
so you always, for a side, you need to check that first. But it's an easy check, right? You just have to remember to do it. So which one of these is going to be our biggest angle?
Q.
R.
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 So I'm going to say that R squared is equal to P squared plus Q squared minus 2 times P times Q times cosine R. Everybody okay here? Okay. My suggestion to you, when I said Q, I meant to write the number, not the letter. I meant to write the 8. My suggestion to you, I'm not going to simplify anything. I'm going to just rearrange this to get the R by itself and then type the whole thing into the calculator exactly as it's going to look like on my sheet of paper. And I think even in general here, it might be worth doing this with just, with the letters rather than with the numbers. So let's try doing it with just the letters first. Okay. So there's my law of cosines. I want to get the R, the capital R by itself. What's the first thing I would do? What's up?
Could you flip the R square and the cosine square?
No. I'm just going to subtract P squared from both sides. And yep, right on. So the next thing we'll do is subtract the Q squared then from both sides. Okay. Good. Now what? Yeah, what are we going to divide by? Negative 2 PQ. That's good. Is everybody still following along with me? We're doing okay here? Then how do we get rid of that cosine in front of the R? Cosine inverse. Excellent. So we have that cosine inverse of R squared minus P squared minus Q squared over negative 2PQ is equal to R. Everybody's cool there? So I'm just going to treat that like my formula. So I'm going to have R is cosine inverse of 10 squared minus 5 squared minus 8 squared divided by negative 2 times 5 times 8. And that's how I'm going to type that into my calculator. In my experience, a lot of students make mistakes here, and it's just a matter of like getting it into your calculator the right way. which is like purely an order of operations thing, I think it's much, much easier to leave it all the way it's supposed to be and to just kind of type it in the way it looks on your sheet of paper than to simplify a bunch of stuff along the way where you give lots of opportunities to make order of operation mistakes. If you just kind of keep everything by itself and let the calculator handle it, the calculator tends to do a pretty good job on doing that. So there's my value for R. So I get 97.90 for R. Now, because this is an obtuse angle, it doesn't really matter which side or which angle I solve for first. But we should get in the habit of, or if this was an acute angle, then we need to be careful. I just get in the habit of always treating this angle as if it was an acute angle and finding the smaller of the remaining angles next using the law of sines. Which angle is going to be my smaller of the two remaining angles? P. So I'm going to say that I have sine of R over R equals sine of P over P, which was 5. So we cross multiply, giving me 10 times sine P equals 5 times sine 97.9. We'll divide both sides by 10 to get the sine P by itself. And then to get rid of that sine in front of the P, we do sine inverse. Sine inverse, I'll make my fraction, 5 times sine of that previous answer, divided by 10, and I get 2969. And then lastly, I'm going to get my angle Q. And that's easy because it's just going to be the triangle sum theorem. So 5241. So far, so good? So in general, I think these law of cosines problems are quite a bit easier than the worst case scenario law of sines problems. Because there's really only, order matters a little bit when you're solving inside, but it's still a lot less complicated than that ambiguous case situation, right? Yes, Brett. Of course. All right. Last thing we need to talk about here are areas. Okay, geometry, what's the area of a triangle? Not the Pythagorean theorem.
A equals
Pi,
One
isn't
half.
it pi r?
One
No.
half.
One half
One
BH.
half times base 10.
Great.
Hey, that's good, right?
So, in my picture, which side is the base? Okay. Make it that one, sure. Then what's the height? Which side is the height?
You have to draw like a dot
Yeah, you
line
just do it.
down.
None of the sides are the height. That's correct. Boyd's right. The height would be this, right? What's the pain about this formula?
Figure out the height on your own.
If you're not given the height,
Then-
that's a rough one.
I think just do this one.
Yeah, I don't know.
Well, there are two other area formulas for a triangle that don't rely on the height. So one of them is well, these are all equivalent. Right, so depending on what you're given, any of these is okay. So just to kind of see what's going on here, for example. Let's say we look at just the first version of this same formula. What three-letter combination is this? Is this like side, side, side? This is side, angle, side. Right? So if you have a side, angle, side situation, boom. We just fill in the two sides and the angle and we're done. What happens, what would you do if you're given like a angle, side, angle situation? Where you don't have two sides. Well, we'll just do the law of sines to get a third side, or to get a second side, and then I can use the formula from above. Oops, sorry, get a second side. Right? So if I don't have enough to do that formula there, I can just do the law of sines to get a second side. And then I can plug it into the formula now because I'll have two sides and an angle between them. So I'll be good. Or what else can I do? I have this formula. So what should I use in this case? Or what case would I use this area formula? What three-letter combination? It's the side, side, side situation. We can just use this formula. Let's do a couple of quick examples, and then that's it here, homies. So just go ahead and now draw our picture. Okay, what situation is this? Side angle side. So the area is just going to be 1/2 the two sides multiplied together times sine of the given angle. And I'm done. I just type in my calculator. What? Isn't that much easier than trying to muck around figuring out what the heck the base is supposed to be? Abso-fruitly. So I get 9207. And now here's something that Mr. Kulik's going to be picky about. What unit should be attached to this? Close. Squared, because it's an area. So if I'm giving you a unit, I expect a unit in my answer, and I expect the degree of the unit to match whatever we're asking for, whether it's a length or an area. Area should be squared, length should not be. But that's it. Like, that's not a big deal, right? What if we have this guy here? What situation is this? Shouldn't even have to draw the picture for this. This is a side, side, side situation, right? So I'm going to use that second formula. By the way, this formula has a name. This is called Heron's formula. I think he was an Egyptian mathematician, Heron was. Oh, like, well, I think it was in Alexandria, so it would have been post-Alexander the Great coming through. So it's, you might as well call him Greek at that point. But pre-Christ.
Yeah. Back in the good old period.
Yeah. All right, so all I'm going to do is plug these numbers into my formula, right? So my S should be 5 plus 8 plus 10 over 2. So that's going to be 23 over 2. Or maybe I'll just call that 11.5. So my area should be 11.5 times, what's 11.5 minus 5? 6.5. What's 11.5 minus 8? 3.5. And what's 11.5 minus 10? 1.5.
So under Heron's formula, it's Heron's formula, it's like S equals the side length divided by 2.
Because, like, who wants a formula with all that fractions and gobbledygook in there, right? When all you're going to do is be plugging it in. So I got about 19.81. And the unit there should be meters squared.
You're so real.
That's whatever.
Like, how nice and easy is that one? All right. At this point, you guys should be able to do the whole of the problem set. I know. If you haven't started, boy, oh boy. Well, we're up to 30.
Is it all due on Sunday?
Wait, what grade is she?
Yeah.
30?
I see we have a test Friday.
Tentatively.
You have a test Friday?
Well, we just
Test
finished.
Friday? What's up with everyone? Mr. Coolest.
I have a psych test Friday.
What? You have a psych test
Well,
You have a test?
here.
No, I was Tuesday.
Jesus.
Just take a deep. Everybody.
You're right. We have Monday off. Yeah.
Shh. Everybody, take a deep breath.
Get to use my rock.
Take a deep breath. Take a deep breath. Listen. If you want to push the test another class period, that's fine. Well, I'll start the next chapter in the interim. No big deal to me. If it helps you guys out, I'm happy to do the test, not on Friday, but the following A day. Sure, no problem.
Thank you.
Right?
Because over
Some
here
of us
is
with other
another test.
Somebody's already complaining about test conflict. Okay, if that's helpful to you, I don't mind doing that. We'll just keep doing stuff, but like the test can be whenever. I don't really care. You know? So, just FYI, we've just finished
7.
the chapter. What haven't we done yet in addition to the test? What might be a good thing to expect next class?
Homework quiz.
Okay.
I'll do homework.
Wait, so what do you want? Can you do it?
Okay. Any questions for me about anything schedule-wise? I'll update the My Notre Dame here when I get a chance to reflect the test not being Friday. That's fine.